We're now going to turn our attention to something called states of matter that you actually are already familiar with. Everybody knows that water, for instance, can be found in either the solid, the liquid, or the gas state. And we refer to those states as ice, or water, or steam. But now we want to take a closer look at what specific characteristics describe matter when it's either in the solid state or the liquid state or the gas state. So this table summarizes the major characteristics of each state or phase of matter. Let's take a look at shape, the first of the characteristics. And we all know that when we look at matter that's a solid, for instance a tabletop or a block of ice, we know that that matter as a solid has a definite shape. It holds its shape. If we take that matter and change it to the liquid state, we notice that something is very different. The matter no longer has a definite shape. We call it a fluid because it assumes the shape of its container. The same thing is true about matter in the gas state. So both liquid state and gas states, matter has no definite shape, will assume the shape of the container that it is in, and can be referred to, both of these states, as fluid states of matter. Let's take a look at the next characteristic, volume. Matter in the solid state has definite volume. That means you can't compress it or squeeze it into a smaller volume. So solids have definite volume, liquids have definite volume, and I think I didn't finish this spelling here. Neither solids or liquids are compressible, not compressible. You can't squeeze them into a smaller volume. But gases, on the other hand, have no definite volume. What that means is that they'll expand to fill whatever volume of container they're in, and you can easily compress them into a smaller container volume. Let's take a look at the next characteristic, which is particle arrangement. If we could have this superhuman vision and look at the particles that make up matter, either atoms or molecules or ions, what would we see? If it was a solid, we would see that these particles are vibrating in fixed positions. So the particles of matter are in very close contact, but they are not able to move around past each other. They are vibrating only in fixed positions. So they have no translational movement. They cannot move from point A to point B. They're stuck in fixed positions and just vibrating in those fixed positions, very close together. Essentially no empty space, which explains why they have a definite volume. Liquids, on the other hand, the particles that make up a liquid are able to move translationally. They're able to move from point A to point B. The movement is random, though. They are in close contact with each other and randomly moving and sliding around past each other. Because they are in close contact, liquids are also not appreciably compressible, meaning they have a definite volume. There's very little empty space. Gas particles, on the other hand, the particles are in random motion, but very far apart from each other. So moving randomly, but very far apart, lots of empty space, which is why gases have no definite volume and are easily compressible. Let's take a look at particle interaction. How do these particles attract to each other? If we're looking at matter in the solid state, particles have very strong attraction for each other, and that's what is essentially holding them in fixed positions, this very strong attraction. In the liquid state, particles still have strong attraction for each other, but that strong attraction is not as evident as in the solid state, which enables the molecules or atoms or ions to slide around past each other. They're attracted to each other, but that attraction is not so strong as to hold them in fixed positions relative to their energy level. So there is random movement and sliding past each other. By the time you have matter in the gas state, there is essentially no attraction for particles for each other. So they have no tendency to stick together in close contact. Very little, essentially negligible, no attraction for each other. Last characteristic that we want to talk about is movement. And I've already referred to this, but let's just shine a spotlight on it. If we are looking at matter in the solid state, the particles are moving very slowly, essentially vibrational movement only in fixed positions. If we're looking at matter in the liquid state, the particles can slide around past each other, but their movement is slow movement, right? So a little faster than solids, but still slow movement, able to move and slide around past each other. And of course, I'm saying slow relative to gases. By the time we're looking at matter in the gaseous state, the particles are moving incredibly fast, very fast, colliding off each other elastically. What does that mean? They're not losing any energy when they collide with each other. They just bounce off without any loss of energy, without slowing down. And you essentially have these elastic collisions, perfectly elastic collisions when matter is in the gas state. Let's take a look at phase changes, how states of matter can change from one physical state to another, known as a phase change. And we would call these examples of physical changes because we're not changing the identity or composition of the substance, just the physical state or phase that it's in. So notice I have the three states of matter listed vertically and in increasing energy, right? So as we move from the solid to the liquid to the gas state, what I'm trying to convey here is that this is a movement to an increasing energy state. Liquids are more energetic than solids. And we understand that because if you want to take a solid and convert it into a liquid, you have to heat it up. You have to give it energy in order to accomplish that change of state, that phase change. So you are moving to a higher energy state as you move from a solid to a liquid and then a liquid to a gas. There are specific terms that we use for these phase changes that you're responsible for, and some you already know. No surprise that conversion from the solid state to the liquid state is known as melting. And conversion of a liquid to a gas is called vaporizing. If we go in the reverse direction and take a gas and convert it back into a liquid, we say that we are condensing the gas. And if we take a liquid and cool it down, so I should mention here that the reverse direction involves moving to a lower energy state, meaning you have to remove heat or energy in order to accomplish this phase change. Cool it down, lower the temperature to take a gas and condense it to a liquid, to take a liquid and freeze it and form a solid. There are two other changes that I'm indicating here, not as familiar, but observable under certain conditions with certain substances. Some substances, under the right conditions, will convert directly from the solid state to the gas state, bypassing the liquid. They never form a liquid, they just immediately convert from the solid to the gas state. And that change is known as sublimation. Sublimation. And also, I should mention, that would involve an absorption or an increase in energy. If we went in the reverse direction, if we took a gas and removed energy from it to reform the solid, bypassing the liquid state, so it just moves directly from the gas, boom, to the solid state, we would call that phase change deposition. So sublimation, deposition. And then giving an example of this process using the very, very familiar, most abundant substance on the planet, water, we see on the planet's surface, water, we see that water in the solid phase is referred to as ice, and you can melt ice and form water. And if you use the term water to a chemist is understanding that you're referring to water in the physical state of a liquid, hence the lowercase l. Ice, water is in the solid state, hence the lowercase s. And then you can take water, add energy, and convert to steam. And if you use the word steam, a chemist is understanding that you're referring to water in the gas phase. So we are familiar that ice can melt and form water. Water can vaporize and form steam. Steam, if cooled down, will condense and reform water, and water, if cooled, will freeze and form ice. All of these changes are physical changes because we see that we have the same substance, same identity, same composition present at the beginning and end of these changes. We have not changed the identity of the substance, so phase changes are example of physical changes.